trigonometric functions. Limit of trigonometric functions. Consider the sine function where f of x is equal to sine x, where x is measured in median. The sine function is continuous, therefore, limit of sine x as x approaches to c is equal to sine c. So cos sine theta is equal to x, sine theta is equal to y, tangent theta is equal to yx, secant theta is equal to 1x, cosecant theta is equal to 1y, cotangent theta is equal to xy. So let's have an example. Find the limit of sine 6x over 5x as x approaches to 0. So let t is equal to 6x, or x is equal to t over 6 when x approaches to 0. T is equal to 6x approaches to 0, so that limit 6x rather over 5x as x approaches to 0 is equal to limit of sine t over 5t over 6. So it's equal to limit of 6 over 5 sine t over t as t approaches to 0 is equal to 6 over 5 limit of sine t over t as t approaches to 0 is equal to 6 over 5 raised to 1, or 6 over 5. So our final answer is 6 over 5. Example number 2. Find the limit of sine 4x over 4x as x approaches to 0. So let t is equal to 4x. When x approaches to 0, t is equal to 4x approaches to 0. So that limit of sine 4x over 4x as x approaches to 0 so is equal to limit of sine t over t as t approaches to 0. We now use the theorem limit sine t over t as t approaches to 0 is equal to 1 to find the limit. So find the limit of limit sine 4x over 4x as x approaches to 0. So is equal to limit of sine t over t as t approaches to 0 is equal to 1. So example number 3. Find the limit of x cosecant x as x approaches to 0. So we first use the trigonometric identity. Cosecant x is equal to 1 over sine x. So limit of x cosecant x as x approaches to 0 is equal to limit of x over sine x as x approaches to 0 equals limit of 1 over sine x over x as x approaches to 0. So the limit of the quotient is used. So is equal to 1 over 1 or 1. So that's the end of my presentation.